I'm Bryce Barker, and this is Mia Smith. And for our developmental project, we decided to work on stride development over the lifespan versus the anatomy or biomechanics.
And our idea for the premise of the study kind of was derived from the idea that in this class we focused a lot on outside factors that influenced a person's trajectory in life, how they changed mentally or emotionally or spiritually, and kind of stuck in the head because it's psychology, right? Well, we wanted to put that to the test. Both of us are exercise science and wellness majors, and we love the body, so we wanted to see if any of these outside factors like family, parents, siblings, coaches can have an influence and actual anatomical impact on the biomechanics or how a runner runs.
And so, just the main question we decided to go for, you can go back there, is there a correlation between outside influences regarding running motivations and the current anatomical biomechanical features of a runner that they've developed into? Okay. And so what we did, we decided to take 6 of the top runners from BYU's rugby team, which Mia is also a part of, right there. And then we had them go through a test just to see, take videos of their running and then give them a survey to try and look at their biomechanics through just technological standpoint, and then a survey of a retrospective study.
Yeah, so Dr. Hunter was kind enough to let us use his lab. It has a really expensive treadmill in there that allows a person to measure all the forces and so much data on the mechanics of how someone runs. And so we brought them into the lab, and this is what it looks like. So these are 3 different girls that we brought in, and then the system will take the anatomical features on the body, such as your the top of your hip bone or certain anatomical features of the bone, and overlays an accurate skeleton on it, and that can give us a bunch of numbers. And if you can see, they all run just slightly differently, and that's what was very curious to us. And so we studied that.
Mm-hmm.
That treadmill was super special, and that skeleton was really cool, but it also gave us a lot of information that we could handle with almost too much. We had to narrow it down a lot.
Oh yeah.
Some things it was able to give us though was the peak body weight force, so that's how much someone is pushing or exploding off of the ground as they move forward in a run. Something else of importance is how much vertical displacement, so basically how bouncy they are when they run. Another thing that I wanted to look at was hip angle extension and flexion, so how much they are pushing their leg back and how much they're bringing their knee up while they run. So we looked at all of those. Also, one other thing was how much separation there was between their knees as they're in full stride position. And we were able to analyze a lot of this data. This was cool to see. This red line here is how much they weigh, and then the blue line is how much force they're able to push into the ground. You'll notice that some of the red lines are under where the blue line reaches. That's implying that they're able to push more than what their body normally would be able to do, implying that they are very strong. That's also very prominent in sprinters. They can exert a lot of force because they have to push harder than, say, a distance runner would have to. Same thing over here, we noticed some differences in the runners, both in how bouncy they were. Some people changed a lot, and some people were very kind of around the same bar and how much displacement vertically they had. And with the extension and flexion of the hip, some of them had a lot of pushing their knee back really far, and some of them brought their knee up very, very far. So there's a lot of cool differences even in this small group of 6 runners.
Mm-hmm. Awesome. And so then, after getting all of that information, I focused more on getting kind of the retrospective psychological influences and maybe what social influences they had from parents, coaches, just siblings or friends. And so the first thing, or a question we had on there, was kind of the availability of school athletic programs or clubs. And so on our little graph here, it'll show that like through elementary, kind of just like that early child or like late childhood years to adolescence, and then through adolescence. So elementary school, it was a 2-to-1 ratio of students that had athletic programs available or sports activities. And then in high school, there was like each high school had an athletic program. And so actually I can do that. So then we wanted to go support from the parents. And so you'll see that it's like, we did it on a graph or a bar from 1 to 10 on highly supported at 10 and then not involved as like the parents or siblings were in their physical activity or their sport participation. So at a young age, it was just, like kind of in between. Yes, it was influenced, but there's not too much. And then it gradually became more and more as the students got more involved or like were influenced or put into clubs by their parents. And it started to increase around 6 to 12, like early childhood through adolescence, a lot of support there. Then I looked at how like they got coaching. So because we wanted to look kind of how the coaches had maybe influenced stride development or to connect that back to biomechanics. And so where they had actually learned, because parents can only do so much with support. And it looks like that in their adolescence years, like 12 to 18, each one of our subjects had an influence from coaches or programs, parents, team leads, in some form of teaching or training on how to run and how to like properly do their sport. And if you notice on this next graph, with the coaching, we asked how motivated was each runner to run during the following ages, which is again early, late childhood, adolescence, and then early. It spiked in adolescence. We had, I think, just like most of them, or most of our subjects, were highly motivated at 10. So once they were properly trained, their strides became better, they actually had proper form. And so just with coaching or mentoring, we believe, or like there might be a little bit of a correlation on how you're coaching, or just like when there's coaching or proper teaching, we're much more motivated to do something in general and maybe have some health benefits because of it.
Yeah, and we wanted to conclude this presentation by kind of touching on the subject of why does it matter that we studied this? What's the importance of this data that we reaped? There's actually a research team on campus that is called the Strong Youth Project, and they focus on youth sports and involvement in like sports throughout the developmental periods of early childhood all the way through late adolescence. And we think that this data could really help them because our version was kind of a retrospective. We took the early adults and then looked back into their history of developing the stride they have now, and they're doing the opposite. It's prospective. They're focusing with the kids and trying to get them to achieve still a healthy body, a healthy lifestyle by the time they're early adults.
Yeah. And just like I was saying before, so the more mentoring, the more like participation and support we get from the parents or coaches or just like people trying to get these youth involved, the better strides, healthier benefits. We've learned from the book that there's going to be, it's like kids need a lot more physical activity, and so that's what we're hoping to do with these kind of correlations that we draw.
Yeah.
And so
thank you very much.
Yeah.